at this problem. To start, aqueous sodium oxalate, we got a formula, is added to aqueous lanthanum 3 chloride, precipitating lanthanum 3 oxalate, and you're given a molar mass. 30 milliliters. It's written 30, so I don't know how many sig figs does that have? Maybe 3. Maybe 2. I don't know, maybe 3. We have a concentration, should be molar, 0.2000 molar sodium oxalate are added to 25.00 milliliters of lanthanum 3 chloride, and we have a concentration of 0.1500. So here we have a net ionic equation. You need to pay attention to the stoichiometry here. Right? It is 3 moles of oxalate react with 2 moles of lanthanum 3 to form 1 mole of lanthanum 3 oxalate. We're going to do 2 questions. The first question is, how much product do we get? How much of this can we collect, assuming 100% yield? So there's your question. The next question that we're going to look at in a different video is, what's the concentrations of all the other ions that don't react? What's the concentrations of everything else left in solution? So first question, how many grams? This one is the easier one, I think. So what you need to do is consider one reactant and consider the other reactant. So your first reactant that they mentioned is sodium oxalate. So we take our volume, we convert to moles of sodium oxalate to moles of oxalate, because that's the thing doing the reacting. Then 3 moles to 1 of lanthanum 3 oxalate. This is the step that makes it stoichiometry, just for your reference. And then 1 mole of lanthanum 3 oxalate is 541.86 grams. So you do the math and you come up with 1.08. I think 3 sig figs is the most you could come up with. Maybe there should only be 2. I just gave that one 3. All right, so that's sodium oxalate. You need to know what numbers you're looking at. This means if all of the sodium oxalate that was here reacted, we could get 1.08 grams. But we don't know if that's true until we check the other reactant, because every 3 units of oxalate needs 2 units of lanthanum to react. So we write our volume of lanthanum 3 chloride. We use the molarity to convert to moles of lanthanum 3 chloride. Now we have moles of lanthanum 3, 2 moles of lanthanum 3 to 1 mole of lanthanum 3 oxalate. Again, that is the stoichiometry step. If you're using coefficients in equation, it's stoichiometry. Now we got 1 to 540. We end up with 1.016. So this is smaller. That means this is the amount of lanthanum 3 oxalate produced, making lanthanum chloride, lanthanum 3 chloride, your limiting reactant, more specifically lanthanum, because the chloride is not reacting. The chloride in this reaction is a spectator ion. Next, we'll look at a second question. What are the ions left in solution?